Hello, class. This week article, I want to talk about the other Nobel Prizes. I'm fairly chemistry centric and even science centric. I know Nobel Prizes are more than just natural sciences. Although Alfred Nobel was really into natural sciences, and although he hoped his name would be associated with peace. But I'll send you the link for this. This is the Nobel Prizes for 2023. And here's in physics. Physics I'll talk about in a second, deal with attosecond laser pulses. I already mentioned chemistry with the quantum dots. And then physiology deals with mRNA, which is the basis for the COVID-19 vaccines for Moderna and BioNTech, which is a German company, which we refer to as Pfizer. Well, Pfizer is a different company, but Pfizer licenses BNT's technology. So, and then briefly mention here is Nobel Prize in Literature to John Foss. I don't know if I'm saying the name correctly, and I'm Narges Mohammadi. So John on his innovative plays and prose which give voice to the unsayable. And Narges, who says, for our fight against oppression of women in Iran and our fight to promote human rights and freedom for all. So if you haven't noticed, Nobel Prizes are very political, and you can see Iran there getting the Nobel Peace Prize, and there's also, as of this week, a conflict started in the Middle East, right? Specifically Israel. So it's interesting to see how this, but the Nobel Prizes have always been very political. And I can talk about it a little bit in a second. So here is, I like chemical engineering news because obviously I'm a chemist. So I'm sending you also this article, all these science concentrates. So the medicine or physiology Nobel Prize was given for the mRNA. This is a little misleading. It's not necessarily for vaccine research. It's more I believe the Nobel Committee gave it because these two scientists here they more studied about mRNA itself and how to elude the body's innate immune response. So you have, there's many parts to your immune system. There's the innate immune response, and then there's the adaptive immune response. That's a great oversimplification. Your microbiome is part of your immune system, for instance, and there's other parts of your immune system that you, like your skin itself or your stomach acid, right? So it's a multi-layered thing. But as far as your body's immune response, there's two parts. There's the innate response and there's the adaptive response. The innate response is just your body it's like having a fever, feeling achy, you're having your selves self-program death. These are the innate responses, and that's one of the problems of COVID-19 for patients that are naive to the virus. Naive, it means it never felt it before. You get infected, and then it escapes detection in your immune system, and suddenly your body's like, oh man, I'm really sick, and it ramps your innate response up really, really high, and that's when it causes damage to people. That's where a lot of the deaths happened, at least initially, for like the original strain and the alpha through the delta variants. So anyways, these individuals looked at evading mRNA. I personally, I'm torn on this. This may be a little bit of an FU from the King of Sweden here, because the obvious person not in the room is Moderna. And partially for me, I have a science crush on Moderna. Moderna is by far the leader. By far the leader in this mRNA technology. And their delivery system is better than BNT or Pfizer, as we say, like with the vaccines. And all the money is, not all of it, but vast majority is being put into Moderna, and they're the one looking at individualized medicine. Maybe next year or a future year, the Nobel Committee will give individualized medicine to Moderna, I don't know. But I really think I mean, as you can see, well, chemistry had 3, physics has 3, and so they have 2 for physiology. They could have put a third, right? But that's my own opinion. I'll give the Nobel Committee the benefit of the doubt, and say that they were looking at the delivery mechanism, which Moderna does better than both of them, But hey, the other thing about Nobel Committee, they really like academics. So as far as the science prizes, they almost exclusively give them to academics. So another example, the Haber process, or the Aber, I guess Haber, I'll use Aber-Bosch process for making ammonia synthesis. So Aber was a German scientist, and he figured out it's about making ammonia. And ammonia is used for fertilizer and eventually also explosives. But the original process uses osmium, and osmium is more rare than gold. So, I mean, and Nobel Committee awarded Aber the Nobel Prize for his ammonia synthesis. But there was a scientist named Carl Bosch who really developed the process, and he's the one that really developed the ability to make ammonia. He didn't use osmium, he used iron, and specifically iron from Sweden. So he tried a bunch of different catalysts, and not only that, just the catalyst, but he also figured out how to handle like high pressure hydrogen. So there was a lot of technology that went into it, and so I guess so. The Nobel Committee oftentimes doesn't look at the technology, people actually doing the things, and they look at kind of the academic people that got there first. So I guess that's kind of in line with them excluding Moderna from this, because I mean, Moderna is looking at the individualized medicine and actually looking more for cancer treatment than vaccines. Although I hear their advertisements on the radio for their Spikevax vaccine, so they're also looking to make money. But hey, so that's the mRNA vaccine. That's the Nobel Prize in medicine, and then the physics prize, and it's looking at people that developed attosecond science. So and grad school, I didn't do attosecond. I worked with lasers, and I worked with nanosecond and picosecond lasers. So nano is 10 to the minus 9, pico is 10 to the minus 12. After that is femto, or I should say before that. Smaller than that is femto, which is 10 to the minus 15. And then atto goes to 10 to the minus 18. So these are really, really fast laser pulses. And so they just tell more information. And this is what the physics people were looking at. It was more looking at like the attosecond science and much of the applications, and it's actually really interesting to see a Nobel Prize like this, because this is really basic science. I mean, this is, I mean, real basic fundamental discoveries. So, I mean, the chemistry prize on quantum dots, it was kind of a how-to, and also leading up to that. So, I mean, it's almost kind of, academic driven technology, and the Nobel Prize in Physics, this is like really basic science. We've discovered how to do something, and we can start to measure things in attoseconds. And so it is a big jump. And this is something that we're trying to find applications for. I mean, I think we will. And I mean, there's just a lot of problems when you're working with attosecond pulses. I mean, even femtosecond's really hard to deal with. And attosecond is even harder to deal with. A lot of it also including with the Heisenberg uncertainty principle, where you get for a set time, you're going to get a big spread of energies. So, I mean, where you have just the basics of uncertainty, which is really beyond the level of these courses. But if you want to study more about Heisenberg uncertainty principle, the energy is going to be uncertain as well. With the time uncertainty and the energy uncertainty is it's going to be it's an interesting problem when you're dealing with these energy with these laser pulses So whereas if you know the time really well, you don't know what the energy is, kind of thing, and you run into that problem with attosecond pulses. So here are those. I just wanted to focus this video on the other Nobel Prizes, especially the ones in science, because it's a science class and I'm a scientist, right? So it's kind of my thing. So hopefully you enjoyed it. There was actually lots of cool articles that came out. I was struggling on what to talk about. I want to talk about the Nobel Prizes, but there are two other ones in this issue. Maybe I'll get to next week. It depends on what they put out. Sometimes they skip weeks, and sometimes there's boring articles. So, but the two I saw were kind of cool. Anyway, if you're wondering, it was on synthetic meat and ocean mining. So, but we'll see. We'll see when I get to that. So I hope this video finds you well, of course. Let me know if you need anything. Whatever it is you need help with. I mean, more than just, of course, academics. I'm here to help. Primarily, that's my main focus is academics, but other things, let me know what I can do to help, and I will do what I can to help. And also mental health. Don't forget the mental health. It's very, very important, and to be happy. So, well, on that note, aloha for now. Goodbye.